All right. Well, hello, everyone. My name is Daniel Packer. I'm a research associate at Washington State University within the Sustainable Seed Systems Lab in the Department of Crop and Soil Sciences. I have been here since 2016. I primarily work on quinoa breeding and quinoa agronomy research. Kevin Murphy is the principal investigator for our lab, and he's going to be presenting today as well. And hopefully between his presentation and my presentation, we can give you a good overview of the work that we do with quinoa here at Washington State University. So with that in mind, I'd like to divide my presentation essentially into three different parts. First of all, for those of you who are not familiar with the geography of the United States, I'd like to provide an overview of what we mean by the Pacific Northwest region of the United States, and then a few factors that influence quinoa production in this region. And then a little overview of the experimentation that we've done with quinoa here at Washington State University, the results that we have obtained, and how those results inform the breeding work that we do. So to introduce you to the Pacific Northwest, if you look at a map of the continental United States, the northwestern part of the continental United States, the states of Washington and Oregon are what we mean by the Pacific Northwest region. Broader definitions of this region will also include northern Idaho and far northern California. To give you an idea of where this region is in relation to other parts of the globe, if you look at the location for Portland, Oregon, which is in the central part of the Pacific Northwest, it's at about 45 degrees north. For those of you who are familiar with quinoa production in South America, in many ways, the Pacific Northwest of the United States is analogous to the southernmost quinoa production regions in Chile. This is a region with a Mediterranean precipitation pattern, with most of the rainfall occurring in the wintertime. It has cool, wet winters and dry, temperate summers that tend to be very friendly for quinoa production. Now, here at Washington State University, naturally, we work primarily within the state of Washington. And what I'm showing you here is a Google Earth image of the state of Washington. These red diamonds that you see here are locations where we have had quinoa trials within the last few years. One of the things that you'll notice within this image of Washington State is that there is a clear east versus west divide in terms of the climate. There is a mountain range that divides the state into two parts. These are the Cascade Mountains. East of these mountains, the climate is quite a bit drier, and then it has more temperature extremes. It tends to have hotter summers and colder winters. West of this divide, the temperature is more moderate, both during the wintertime and the summertime, and they receive more precipitation. Today, I'm primarily going to be talking about two locations, Mount Vernon, Washington, here in the northwestern part of the state, and then Pullman, Washington, in the southeastern part of the state. These are our two primary research locations, and in many ways contrast the different growing environments that we have here in Washington State. So to give you just a little bit of comparison between Pullman and Mount Vernon, quinoa is generally planted both in Pullman and at Mount Vernon in either April or May. We have a growing season that is about from April to September, and so quinoa flowering generally occurs in July. And if you look at the average maximum temperature in Pullman, in July, we generally have 27.7 degrees Celsius, and Mount Vernon is a little bit more moderate, 22.5 degrees Celsius. But both of them are very comfortable for quinoa production. Now, for those of you who have been following the news in the United States, you know that in the Pacific Northwest United States, we've been having a really unprecedented heat wave. Yesterday, Pullman reached 40 degrees Celsius, and we're going to reach 40 degrees Celsius again today, and we are still in June. Regarding precipitation, quinoa receives about 538 millimeters of precipitation. Mount Vernon receives more precipitation, 856 millimeters of precipitation, again, with most of that rainfall occurring during the winter time. However, at Mount Vernon, because of the proximity to the Pacific Ocean, you can get rain events during the growing season. Now, the biggest difference between these two environments that I think applies to quinoa production is the amount of relative humidity that exists at these places. So even though in 2021, this is just an average of the relative humidity since May 1st, even though we've been in a drought year here in 2021, Mount Vernon has still maintained a very high level of relative humidity compared to Pullman. And that's consistent with what I have seen. So like I said, I arrived here in 2016, and in 2016 and 2017, most of our quinoa breeding research was occurring in Eastern Washington in and around Pullman. This is where our primary breeding nurseries were at and our main variety trials. We did have trials in Western Washington. We had on-farm trials, we had variety trials and graduate student projects in Western Washington, where primarily Pullman was our home base. Now, we definitely can produce quinoa in the Pullman region. However, we have several concerns, or we have had several concerns in producing quinoa in this region. I'd like to walk you through some of those. What I have here are the results for the variety trials that we had from 2014 to 2017. If you look at this chart, you can see that 2014 was the best year that we had, with a mean yield of 350 kilograms per hectare. But that was a pretty wide range. We had entries going from 1,100 kilograms per hectare down to 41 kilograms per hectare. 2015 was more challenging. The mean yield dropped, but importantly, about 50% of the entries failed to produce at least 100 kilograms of seed per hectare. 2016 doubled down on that trend with very low yields, a mean yield of 13.7 kilograms per hectare, essentially zero. And most of the entries in this variety trial failed to produce any seed at all. Now in 2017, we failed to yield any seed at all. And this is despite going through with the combine, harvesting all the plots, cleaning them, looking for seed as hard as we could, and we could not find any seed in the variety trials in 2017. And we also, in our breeding nurseries, failed to produce any seed within our breeding nurseries in 2017. So for a breeding program, this is a real challenge. In 2017, we essentially lost a year's worth of progress. Now, if you look at these plants in the field in Eastern Washington, these are pictures from 2017, you don't see any obvious stress. There's no obvious heat stress or drought stress that you see in the plants. The vegetative growth is excellent, but you just have a lot of inconsistency in producing seed. And for a breeding program, that's a real challenge. So, like I said, we had trials in Western Washington, and in Western Washington, we saw a very different scenario. We were able to consistently produce seed across all genotypes, and we're seeing consistently experimental yields above 1,000 kilograms per hectare. So we had the hypothesis that for a breeding program, it would be better to do our work in Western Washington, where we could more reliably produce seed on a yearly basis. So with that in mind, in 2018, we made the transition from Pullman to Mount Vernon. In 2018, we planted approximately 2 hectares of quinoa plots, both variety trials, observation nurseries, breeding nurseries, germplasm collections, a wide diversity of materials. We planted these in May 4th, which is a very reasonable time for Mount Vernon, Washington. And another transition that we also did in 2018 is in 2018, we began working with WSU quinoa experimental lines in our variety trials. These are lines that were produced by Julianne Kellogg, who is a graduate student within our program. She's currently pursuing a PhD, but during her master's, she worked with growers in Western Washington and developed over 90 new experimental lines out of 10 segregating populations. And so in 2018, we began evaluating these materials as opposed to some of the more traditionally available quinoa lines. So you can see we began establishing a fantastic crop. The picture on the left is 46 days after planting. You can see some differences between genotypes, but they are not all that pronounced. However, by early August, 90 days after planting, you can begin to see some really prominent differences between genotypes, particularly for maturity, like what we see here in this picture here on the left. The entry that's here in the foreground is starting to senesce. It has likely has mature seed. And these differences became even more pronounced at 124 days after planting. This is the first week of September. As you can see, we have some entries that are completely senesced. The seed is mature, and it would be easy to harvest these materials with a combine. However, we had many genotypes that were still holding on to moisture in their vegetative tissues. So some of these had mature seed, but they still had moisture in the stem and in the panicle, and would be very difficult to harvest mechanically with a combine. So what we did in 2018 in September is we went through and we harvested the central row of each plot. And the reason why we did this is because I had been speaking with a group of growers in July of that year and had told them of my intention to harvest the seed in mid to late September. And they warned me that in Mount Vernon, there's a high risk that the fall rains begin in early to mid-September, and that as a general rule of thumb, grain and seed crops need to be out by early September. So to avoid any kind of risk and to lose all of our data, we went through and harvested the central rows. Now, this was a lot of work for us. And these panicles, many of the panicles had to be dried with forced air and with heat. And for a small breeding program, this was a substantial workload. It took about 3 months to do this type of work. However, about 2 weeks later, 145 days after planting, the fall rains still hadn't arrived, and we were able to bring a combine out, and we're able to harvest every plot. And we were able to harvest seed off of every plot. And it was, we harvested a fantastic amount of seed. It was very different from the experience that we had had in 2017 in Pullman. To show you how well we did, we saw yields that were substantially higher than anything that we have seen in Eastern Washington. If you look at our mean yields, we had 3,200 kilograms per hectare across our trials, with several entries doing over 4,000 kilograms per hectare. So these results that we had in Mount Vernon in 2018, to me, show the promise of Pacific Northwestern quinoa, particularly in coastal environments. However, this being said, I want to contrast what we saw in 2018 with what we saw in 2019. So 2019, in many ways, shows the risk that is involved in producing quinoa in these coastal environments. And I'd like to walk you through what happened. But you can see these pictures and kind of get an idea of what's going to happen. So in 2019, we essentially planted the same trials that we had in 2018. The same variety trials, very similar breeding nurseries. We had very similar planting dates. May 8th, in the case of 2019. To compare 2018 and 2019, I'd like to show you some of the differences in precipitation between these 2 years. The blue bars are 2018, the orange bars are 2019. You can see that in April, we had quite a bit of rain, both of those years. That is why we planted in May. That's pretty standard for Mount Vernon. Generally speaking, April is still very wet, and it's too difficult to get machinery into the field to prepare a seed bed and to be able to plant. In 2020, which was kind of a strange year, I'll talk a little bit about, we also were not able to plant in April because there was too much moisture in the field. 2021, because of the drought, we were able to plant in April, but that's kind of has been an exception. In 2019, it was quite dry across the growing season, while in 2019, we had significant rain events in each month of the growing season. But most importantly, in September of 2019, we saw that the fall rains did in fact arrive in September, and we got quite a bit of precipitation in 2019 in the fall. So in 2019, with this extra precipitation that we had more luxuriant growth in the plots that grew taller. We saw more lodging. At 119 days after planting on September 4th, just like with 2018, we had a diversity in terms of how many plots were ready to be harvested. We had some that were like the ones that are in this picture that had dried down and could have been harvested with a combine. However, to avoid all of the additional work that we did in 2018 with a hand harvest and having to dry panicles, we decided to, or I decided, I guess, to wait until we could bring a combine out 2 weeks later because we had had such great results in 2018. However, that was a severe mistake. Soon after this picture was taken on September 4th, the fall's rains arrived and they did not stop. And this is September 19th, about 2 weeks after that last picture was taken. And as you can see, we had substantial lodging, but you can also see, for example, in these plots here on the left, that many of the entries still had failed to dry down. There's no way these could have been harvested even if they were standing, at least harvested with a combine. For the trials where the seed had in fact dried down and the plants could have been harvested with a mechanical thresher, we saw this in these plots. So I spent an entire day walking through all of our plots, looking for anything that had not sprouted on the head. And I was unable to find anything, either in the breeding nurseries or in the variety trials, that had not sprouted. And this is really unfortunate because we had a tremendous amount of seed on these plots, and I was really looking forward to our results again in 2019 and thought that we were going to see a similar pattern to what we saw in 2018. But this shows kind of the peril of growing quinoa in these coastal regions in the Pacific Northwest and the real need that exists to develop varieties that are specific to this type of a climate pattern where there's a substantial risk for fall rains at the end of the growing season. So with that, as a breeding program, there's many different traits that we're looking at, both agronomic traits and end-use quality traits. But based on the experience that we had in 2019, breeding specifically for earlier maturity and for pre-harvest sprouting resistance really became a priority in a way that they were not prior to this experience. And I'd like to talk a little bit about these two traits. When I talk about breeding for earlier maturity, what I'm talking about is something that is a variety that from planting to harvest can be completed in 110 days. So at 110 days, as mature seed and the vegetative tissues have fully senesced, it is dried down, you could easily cut it with a combine and it's going to thresh cleanly. It's not going to plug the combine, and you're going to be able to have a very easy harvest at 110 days. So 2019 is when we had that experience. So really 2020 is the year that we began really intensely looking at earlier maturity. 2020 was a strange year. We were only able to plant a single variety trial in 2020 because of travel restrictions that we had due to COVID-19. So we didn't have a breeding nursery. But within that variety trial in August of 2020, you could find within each plot individual plants that were showing earlier levels of maturity. Now these lines are quite uniform, but there's still some residual heterozygosity, and so you can find panicles that had earlier maturity. So these were selected with quite a bit of intensity. Now I do recognize that these selections are going to have pretty low heritability, but they were the material that we had handy and could make selections in at that moment. And I do believe that being consistent with this type of a method, you can drive progress in driving materials towards earlier maturity. So these are currently planted in the field out in Mount Vernon for further selection. They're planted out as hedgerows. And also, fortunately for us, we did have 8 populations that are currently in the F4 that were created specifically with earlier maturity in mind. We had those in the greenhouse last winter, and we were able this spring to be able to get 2 of these populations harvested and threshed in time for planting this year in 2021, and we currently have them in the field as hedgerows. And that's what this picture is here down in this bottom picture. And you can see that they're segregating for color amongst other traits. But no, they look fantastic. I'm really excited about both the selections that we made in 2020 and these hedgerows, because I think there's some really interesting new materials in these groups. In terms of breeding for pre-harvest sprouting, there's been very little work that has been done characterizing pre-harvest sprouting resistance in quinoa. If you'd like a good overview of what is known, I would recommend that you check out this publication by Emma McGinty and her colleagues also here at Washington State University. That was published in 2021 that kind of compiles what is known about seed dormancy and related traits in quinoa. Now, to breed for pre-harvest sprouting and resistance in quinoa, we have a real need to begin to lay a foundation for this. Most of the work that has been done with pre-harvest sprouting resistance has been done in cereals such as wheat and in barley, and we need to develop protocols specifically for quinoa. And we have a graduate student, Cristina Ocaña Gallegos, who is currently doing this work. She currently has 350 genotypes in the greenhouse that are planted across 4 different planting dates. And she's going to harvest panicles off of these entries later this year and then place them inside of a misting chamber where they're going to be continually misted with moisture to induce pre-harvest sprouting. And then she's going to phenotype them for pre-harvest sprouting and measure that using protocols that she's currently developing specifically for quinoa using imaging analysis. And so hopefully from her project, we'll be able to have phenotyping protocols that are specific to quinoa so that we can measure variability for pre-harvest sprouting resistance and also identify new germplasm that has pre-harvest sprouting resistance that we can use for making breeding crosses. Another line of work that we are using is an interspecific population. In this case, it's quinoa by Quinopodium berlandieri. Quinoa in this case is Ames 13757, and Berlandieri is PI 666294. We had this population in the greenhouse last year, and currently we have them as hedgerows in the field here this year in 2021 in Mount Vernon. We also had them in the field in Pullman in 2020. That's what this picture is right here. Unfortunately, we lost all of these plots in 2020 to herbicide damage. Herbicide was applied in an adjacent field and it drifted over and did a real good job of knocking out our plots as well. And Chenopodium berlandieri possibly has variability for seed dormancy that may be useful in bringing in pre-harvest sprouting resistance into quinoa. One more thing I'd like to mention, I'm about ready to conclude my presentation here, is a project that is being done by Rachel Breslauer, who's a PhD student in our lab, who is looking at interactions between protein quality and things such as maturity and varieties and nutrient management. And the reason that I wanted to just bring up this project that she has is that as we move forward with these selections, we have to be aware of any trade-offs that may come with that. So for example, if we drive maturity down in a variety from 120 days to 110 days, the question then becomes, what does that do to nutritional quality? What does that do to yield and other things along those lines? And so it's something that we need to keep in mind as we make these selections and do this breeding work, to be aware of any possible trade-offs that we may also be inducing. So that is the presentation I have for you today. You're welcome to contact me with the email that's listed here below. And I appreciate your time and your attention. Thank you.